So in this video, you're going to learn about the different types of chemical reactions. So we're going to start from the top. A chemical reaction is a change that occurs to a substance resulting in the production of one or more new substances. There are 6 indicators of a chemical reaction. Many of you will notice when you're conducting a chemical reaction or you're observing a chemical reaction, these are the things you should use one of your senses to either hear, to see, or to smell. So, first one, color change. Second one, odor. Third one is the production of a gas. Most of you reference the production of a gas with steam. 4, formation of a precipitate. This is a solid particle. 5 is formation of light. 6 is the temperature change. So if it's a endothermic reaction, it's going to absorb heat. And if it's an exothermic reaction, it's going to release heat. So, types of chemical reactions. First, you have synthesis or combination reaction. To synthesize something is to make something. To combine something is to put something together. So, when you have a synthesis or a combination reaction, you're going to be making something or putting something together. Second one is decomposition. Decomposition is, or decomposing something, is to break something down. 3, single replacement reaction. Remember, single means one. So, if you have a single replacement, there's going to be one change or one replacement in that reaction. 4 is double replacement. Double means 2. You're going to have 2 changes, 2 replacements occurring in the reaction. And then everybody's favorite is the combustion. So this is when you would see your fire or explosion. So synthesis or combination reaction, the general equation is A plus B, and that's going to yield AB. The hint here, it forms only one product. Remember, reactants are on the left and products on the right. The example here is 2 molecules of hydrogen gas, 1 molecule of oxygen gas, and that's going to yield 2 molecules of water. Decomposition reaction, the general equation is XY yields X plus Y. You could have also done AB yields A plus B. Hint here, only one reactant present. So the example here is the opposite of the example here. 2 molecules of hydrogen, two molecules of water yields 2 molecules of hydrogen gas plus 1 molecule of oxygen gas. So once again, they're just the reverse of one another. So single replacement reaction, the general equation here is A plus BC is going to yield AC plus B. The hint here is element plus compound, compound plus element. So your element here, it would be A, your compound BC, compound here AC, element B. So an example here, you have 1 atom of copper plus 2 molecules of hydrochloric acid, and that's going to produce 1 molecule of copper 2 chloride and 1 molecule of hydrogen gas. Single replacement reactions use what we call the activity series of metals. It's page number 7 on your reference table. You will get an opportunity to use your reference table. So the chart allows you to see the most reactive elements, and they're going to be listed at the top, and then they will replace each element below it. So as long as any of the elements come above, they can replace anything below it. Double replacement reaction, the equation here is AB plus CD yields AD plus CB. So the hints here, you're going to have a compound plus a compound is going to yield a compound plus a compound. Precipitate will form, and on your product side, you're going to get 2 ionic compounds, but one is going to be aqueous and the other one is going to be a solid. The example here is 1 molecule of barium chloride plus 1 molecule of sulfuric acid, and this is going to yield 1 molecule of barium sulfate plus 2 molecules of hydrochloric acid. So this is going to use the solubility rules, and they describe which substances dissolve in water, and that's going to be on page 6 of your reference table. So, combustion reaction last. The general equation here, you're going to have a hydrocarbon plus oxygen for your reactants, and it's going to produce carbon dioxide and water. So, this would be your word equation. For a chemical equation, this is more so what it'll look like. This is the formula for a hydrocarbon. You typically don't have to worry about this because you will be provided your hydrocarbon. But in any case, Cn, and N will change to the amount of carbon, H2N plus 2, and 2N plus 2 would change to the amount of hydrogen. That's going to be added to whatever your amount of oxygen gas is. That's going to be yield to produce carbon dioxide and water. Those are your hints, because anytime you see any of these things, you know that you have a combustion reaction. The example here, you have ethanol, which is CH3CH2OH, which is a liquid, plus 3 molecules of oxygen gas, and that's going to be yield to produce 2 molecules of carbon dioxide plus 3 molecules of water. Application here. So what we're going to do is identify the type of chemical reaction being used by showing a S for synthesis, a D for decomposition, SR for single replacement, DR for double replacement, and C for combustion. So here we have 1 atom of carbon plus 1 molecule of water. We get carbon monoxide and hydrogen gas. So if you notice, we have 1 element here and 1 compound. Then we get 1 compound and 1 element. So this is single replacement. Number 2, you have 2 molecules of magnesium oxide. That's going to break down to produce 2 molecules of magnesium and 1 molecule of oxygen gas. Notice I said break down, so this is a decomposition reaction. Here we have methane plus oxygen gas, and that's going to produce 1 molecule of carbon dioxide, 2 molecules of water. You have your hydrocarbon, your oxygen, you're going to produce carbon dioxide and water, so this is a combustion reaction. Then we have 4 molecules of phosphorus plus 5 molecules of oxygen gas. This is going to be producing 2 molecules of diphosphorus pentaoxide. So because we took 2 elements and combined them together to make 1 product, this is going to be a synthesis reaction. Then we have 1 molecule of zinc 2 chloride plus ammonium sulfide, and that's going to be yield to produce 1 molecule of zinc sulfide plus 2 molecules of ammonium chloride. So notice we have a compound here, a compound here, a compound here, and a compound here. This is ionic, this is ionic, this is your solid, and this is your aqueous solution. So this is a double replacement reaction. So what you can do is use some of those worksheets that you've now balanced those equations and go back and identify those equations as a synthesis, decomposition, single replacement, double replacement, or combustion reaction. Good luck.